This is a walkthrough of solving for an unknown problem 9. This is a problem in engineering about thermal expansion of materials. This is a expansion joint in a bridge. When it's a very hot day, these teeth are going to come together. It's a very cold day, the teeth are going to come apart, but it's going to be okay to drive on it. You're not going to fall through it, and there won't be any stress in the bridge as a result of the thermal expansion or contraction. The equation that relates the change in length, delta L, that's a capital letter delta, Greek letter delta, indicates change. So change in L. There's three parameters on the right-hand side. Alpha is the thermal expansion coefficient. That's a lowercase a in the Greek alphabet. L is the original length of the material, and delta T is the temperature change. So if you have a big temperature change, you're going to have a big change in length. Part A, what's the change in length delta L of a slab of concrete that starts off 10 meters long when the temperature changes by 30 degrees Fahrenheit? The thermal expansion coefficient of concrete is 6 times 10 to the minus 6th per degree Fahrenheit. 6 times 10 to the minus 6th for every degree. Let's forget about B right now. Let's focus on A. So the equation is delta L is alpha L delta T. We know everything on the right-hand side. The thermal expansion coefficient of concrete, 6 times 10 to the minus 6th per degree Fahrenheit. The original length is 10 meters, and the temperature change is 30 degrees Fahrenheit. We can plug these in on the right-hand side, and we get that. It looks like the degrees Fahrenheit are going to cancel. There's one in the denominator and one in the numerator. The only unit we have left is meters, and that's good because delta L is a length. Now we have to just push the buttons on the calculator, and we get 0.0018 meters. In order to know what that is, I like to put it in a unit that makes sense to me, 1.8 millimeters. A little bit less than the thickness of 2 dimes. That's how much it expands. On to part B. Part B, we have a 30-foot rail that's going to expand by 1/3 of a centimeter when the temperature changes from minus 10 degrees Celsius to 20 degrees Celsius, which is a change of 30 degrees Celsius. What's the thermal expansion coefficient of the rail? This picture shows if you don't leave gaps in the rail, between the rails, consecutive rails, and they have to expand, there's no room for them to expand. The only way they can expand is to buckle, is to curve. That's the only way they can get longer. And of course, this is dangerous if you're riding on a train. So the only unknown here is the thermal expansion coefficient, alpha. There's the equation. We know everything but alpha. Delta L is 1/3 of a centimeter. The original length is 30 feet. The temperature change is 30 degrees Celsius. We have to solve for alpha, and the way to solve for alpha is divide by 30 feet times 30 degrees Celsius. Like this. The right-hand side has only alpha, which was our goal, which is why we divided by 30 feet times 30 degrees Celsius. Now we have this. And you may have noticed we have units problems. We have a centimeter in the top, we have feet in the bottom. We want those to be the same. So we have unit issues to deal with, and let's deal with them. The way to deal with them is to multiply by 1 twice, or once if you know that there's 30.48 centimeters in a foot. But there's a lot of different ways to do it. You can use different conversion factors. As long as you keep multiplying by 1, and eventually you get 2 of these lengths that are the same. If you want, you can convert them both to miles if you're bored. So let's see what cancels here. We started off with alpha, and then we multiply by 1 twice so we don't change its value. These fractions in parentheses are equal to 1 because the top is the same as the bottom. Centimeters cancel, meters cancel, feet cancel. The only unit left is degrees Celsius in the denominator. So we just push the button on the calculator, and we get 0.00012 degrees Celsius per degree Celsius. And if you like scientific notation, 12 times 10 to the minus 6th for every degree Celsius.